go ahead and get started on 11.3. And 11.3.
I have the same answer.
Awesome.
All right. And whiteboard should be there. Use this. Can y'all see my screen?
Yes. Yes.
All right. Now, those of you that are going into Trig, you're going to see this in Trig, not Trig, going into 140, whether it be the summer or whether it be whenever you take it, this is going to be, you're going to see some of this in Calc 2 and a lot of it in Calc 3. All right? Because in Calc 3 and in Physics 2, Physics 3, you're starting to find the acceleration of a particle in space. Okay? And in order to find the acceleration of a particle in space, you have to find the normal vector. Why? Think of a slingshot, the kind that David killed Goliath with, the kind you spin around and round and round. Well, that rock is at the end of a vector. And the centrifugal force of that rock is dependent upon the normal vector. The normal vector to the position vector. Okay, we're going to get to that in just a minute. So, in other words, is this section very important? Hell to the yeah. So make sure you take good notes here, okay? All right, those of you that's not going on to physics or whatever, then just do the best you can, okay? All right. What is a vector? A vector is a word, a fancy word for an arrow that shows direction and magnitude. Okay, write that down. Direction and magnitude. All vectors have a direction and a magnitude. The magnitude is basically the quantity. Hold on, let me wait till everybody gets through the paper. I'm sorry, it's that microphone. It's not you. When y'all turn your pages at Pendleton, and easily it sounds like thunder's crashing. I mean, it just. Okay. All right, it's not your fault. All right, a scalar is a magnitude. You don't have to write scalar. Write scalar, but scalar is the quantity given to the magnitude, to the vector. It could be 10 pounds. It could be 20 feet. It could be 30 miles. It could be 10 grams. It could be any of that. A magnitude is a 25-cent word for quantity. Everybody with me? And a direction is always going to be in degrees. And I don't care what anybody says, nobody ever is going to walk up to you outside of academia and say, well, we're going to change this vector to pi over 3 radians. Nobody. Okay? So a vector quantity is a magnitude with direction, and a vector is represented by the letters with a vector on top of it. So that is your real simple introduction to a vector. The baseline is always the horizontal, unless you're talking about a zenith or a bearing, and that's a different story. That's come off the north. Usually your vector is going to come off of 0 or 2 pi on the unit circle. We're going to talk about unit vectors. We're going to talk about opposite vectors. What's the opposite of 10 pounds? Negative 10 pounds. Negative would be going in the opposite direction, and it would be the same length as that 10 pounds. Now remember, and I'm going to this length of this vector. You don't just draw it wherever you want to. This length is 10. Okay? 10 what? 10 whatever you're talking about. So don't think that's just an arbitrary vector. It has a length of 10. The units may be pounds, may be ounces, may be grams, may be volume. It could be 10 cubic centimeters, it could be anything. And then the bearing, the angle is always off the 0 or 2 pi. Everybody with me?
Mm-hmm.
Now, I don't know how many of you how many of you at Pendleton, just raise your hand, have had a good understanding of vectors in the past? Okay, 1 or 2, 3 maybe. How about easily? Easily, could you turn that camera a little bit to the left, please? Somebody's moved it and the center is, just turn it a little bit to the left. Your right. A little bit more. Thank you. That's where it needs to be. Okay. And what about y'all? Have y'all had, Miss Billy, have you had, and have y'all had an experience with vectors before?
No.
Nope.
Okay. How about you, Miss Payne? Sleep. All right. How about y'all?
No, I'm not asleep, and no, I have not.
Okay, there she is. Thank you. I'm just kidding. I know you're probably not asleep. All right. So, again, I would say probably half the class has seen vectors before, and a little bit less than half the class have not, and 2 or 3 didn't say anything. So, again, I'm going to go from the approach that you don't know anything about it. Okay? So if you're a water walker, you know, before, you know, go ahead and leave class and write down the 5 lottery numbers for me before you leave, okay? All right. Vector OP, vector OP. What comes first in alphabet? O, so it goes first. That's the lettering of a vector. Vector OP is not the same as vector PO. Vector PO is going in the opposite direction. So this is the negative vector to the positive vector. Okay? The positive vector is going to have an initial point and a terminal point. What does initial mean? The start. What does terminal mean? You dead. That means the end. Okay? So OP, that is the initial point, initial vector. You're going to hear initial vector. You're going to hear position vector, you're going to hear unit vector, okay? The initial point is O. The initial point on the second arrow is P. So you can't say, oh, OP and PO is the same. They're not the same. They're going in different directions. Now, we don't know the direction because nobody has given us, but the arrow is going toward P here. The arrow is going toward O here, so they're going in opposite directions. Now, that's very important that people know that. I know it seems basic to some of y'all that know it, but to someone who doesn't know it and never seen vectors, that can be confusing. Okay, you don't have to write this word for word, but basically the first one is a resultant vector using head to tail. The second drawing is the resultant vector by parallelogram. Now, you don't see head to tail because they don't know that you know head to tail yet. Now you know head to tail. Head to tail is when you take the tail end of one vector and put it to the head of what? The other vector, head to tail. And that makes a triangle. Another way to do it is to write a parallelogram and then draw a bisector, and that's the resultant vector. What is the resultant vector? The resultant vector, I don't even know if they got it here, but the red arrow is called the resultant vector. It's going to be called R with a line over it in the future. The resultant vector is what you are finding in a free body diagram. The resultant vector is what physics and dynamics statics and dynamics is made up of. Okay? So, is it important that you know what the resultant vector is? Yes, and it's important that you know it now, because you're going to hear it throughout this section, and you're going to hear it in second calc, you're going to hear it in DiffEQ, physics 1, 2, and 3. Okay? So there's 2 rules. There is the head to tail, and there is the parallelogram. Most of the time in physics, you're going to see this. You're going to see the head to tail. Hopefully some of y'all have seen it. If you haven't, I think most of y'all understand what is the area of a rectangle. 1/2 what? Base times the height. So that's how you get the resultant vector. The resultant vector is the bisector of the rectangle or the parallelogram. So what does that mean? If I have a block of wood here, okay, and I have a I don't know what you call it, a ramp, okay? It's not a ramp because it's not going up or down. And I have 10 pounds going this direction. And I have 30 pounds going this direction. Well, then technically, I've got a 10-pound vector going this way, and I've got a 30-pound vector going this way. So what happens to the 10? It cancels out, and I'm left with what?
20.
20 pounds.
Going that way.
That is a very basic resultant vector. Okay? That's very basic. And anybody knows that if you weigh 100 pounds and somebody weighs 300 pounds, you can forget it. Okay? They're going to push you over. Okay? So that's what we're finding. And when you have a force affecting going down, like gravity, then you've got other forces except for lateral forces or horizontal forces. You got a vertical force, and thus you got physics. And that would be dynamics because you're actually moving, or could say statics also. But statics is when you're talking about dang old pressure, like force on a building, like wind or something. That's dynamic. That's okay. Next, I'll show you. Sometimes I ramble in physics or vectors. Okay. Vectors are commutative. A plus B is equal to B plus A. Now this is very important because when we get in the resultant vector, some of these little properties are going to pay off. Okay? A plus B is the same as B plus A, and a negative vector basically is subtraction. A scalar product, you can multiply. We'll get into that with unit vector. We'll get into that. Unit vector is the magnitude of the vector divided by the magnitude of the vector, basically 1. And we'll get to that. All right? So these two would cancel each other out. And if you had u and you added 3/2 u, then that would be 5/2 u. So if you took those two and added them together, you would have 5/2 u. And then if you took 1 away from 5/2, add 5/2, that would be 6/2. So you could take this one.
This is 0.1.
Yeah.
What is it? What is it, Pendleton?
Nothing.
Did y'all have a question?
No, I think we're okay.
Okay. 3/2 plus 2/2 is 5/2 plus 1/2 is what? 6/2. So if you take the black one, the red one, and the green one, you've got a vector of 3.
Sorry to interrupt.
Is that
You're
me?
anyway. Yeah.
Can you hear me?
Miss Payne, do you have a question?
This dude, Lucas Wilson, is messaging me to add him.
Well, I've tried to add Oconee and nobody was there.
Maybe he's one added owners.
Hold on a second. He's not there. Let me pull him up. Wilson. W-I-L-S-O-N. Lucas.
I'm going to spend the whole entire class period working on one.
There he is. I don't know what's up with Oconee because nobody's up there. Mr. Wilson, are you there?
Why did I label this better?
Mr. Wilson, are you there?
I'm here. Can you hear me?
Are you at Oconee? Because nobody's there.
Right. I texted you. The internet
Something's
is
wrong
down.
with my phone. I just texted my daughter. She got it, but something's wrong with my phone.
Okay.
Are you at Oconee?
No, sir. I'm in Oconee County, but the Oconee campus, the internet just got slashed.
That's why. Okay. Are you with the others, or are you just
I am
by
not.
yourself?
I'm by myself.
Okay. All right. Well, just hang on. I'll make sure I post this because they're gonna need it because the internet's out. I mean, oh, let's see. What's their name? Do you know their other name? Do you know the other one's names? Their last names?
I know Anderson and Abby. One of the last name is Barry.
Barrry or Berry?
I'm not sure about that.
Well, they should have. Let's see. Is it Angela? Well, they're not online anyway, so I was looking to see if they were online. Well, nobody let me know that, and there's something wrong with my phone.
I threw it away.
But anyway, let's keep going. All right, so 2 halves plus 3 halves plus 1 half is 6 halves, and what's 6 halves you? 3. So if you add the black vector to the red vector to the green vector, how do I know I'm adding all of them? Because they're all going in the same what? Direction. Okay? So when they're going in the same direction, you add them. When they're going in the opposite direction, you what? Subtract them. So make sure you understand that. And a scalar is nothing but a multiplier. We'll get into scalars later with the unit vector. Okay?
Oh, can you do my notes?
What kind of question would there be where you would do this?
We're not doing these right now. These are just, the questions that you're going to get are going to be vector questions. They're not going to be like this. I'm not going to ask you, what is this vector? Those are basic questions. I'm not going to ask those. Okay? Just wait. I'll tell you when we get one.
Okay.
Here we go. First good definition. A vector with its initial point at the origin is called a position vector. A position vector is what you're going to hear in Calc 2, Calc 3, Physics 1, Physics 2, Physics 3. You're going to hear that throughout. Now again, I'm only talking to those people that are going that route. So if you're not going that route, then you can just ignore me, all right? Now, a position vector U with an endpoint of AB is written as U is equal to A. Now look at the way it's written. It doesn't have parentheses. It's got those less than and greater than brackets.
That's it.
That's when you know you have a vector. Okay, who's got a question? So I keep hearing people in Pendleton, I want y'all to talk. But if y'all talking while I'm talking, that means you're either you know the material or you're doing something else. So Pendleton, what are you doing over there with the calculator? Are y'all doing homework or what?
Yeah.
Yeah, it's homework.
Okay, you got about 2 seconds to close those. You're not supposed to do homework in my class. Do you understand?
Yes, sir.
That's kind of rude. When are you supposed to do homework?
At 2.
I'm asking you, that means I want you to answer it. When are you supposed to do homework?
At home.
Thank you. I know I'm being unreasonable for you to do homework at home, Anyway, where A is called the horizontal component and B is called the vertical component. Okay, now this is where you get into r sine theta and r cosine theta. Basically what they're going to be showing you is when you have a vector, a position vector, it can be broken up. This is basically the what? The hypotenuse. And you can break it up into its x component and to its what? Y component. Sorry. There. So, if I have a y component, the y component is going to be the sine of theta. I think they're getting into that right now, but I'm wanting to write it out, and it's not. This is going to be the sine of theta, and this is going to be the cosine of theta. Now I'm kind of getting the cart before the horse. Okay? Okay, now I see you're not writing anything. Okay, am I missing something? Pendleton, why are y'all not writing any notes?
I am.
Not all of you are.
I've just included one.
Okay, do we have some people up there that know? That if you already know this material, Pendleton, y'all can leave and I'll give you the final exam and the last test. You want me to go ahead and do that?
No.
Now, all of you should be writing notes. But evidently, y'all got some people up there that know all the material. So congratulations on knowing all the material that I'm teaching. Okay? So if you got the cosine of theta and the sine of theta, you can actually find the x component and the y component. We'll get to that in just a minute. You can also use the Pythagorean what? You can use the Pythagorean theorem. You also are going to be able to use the law of sines and the law of cosines when you don't have a perpendicular vector. Okay? So, with that being said, here is the magnitude of any vector. The magnitude of any vector is the square root of what? A squared plus b squared. Somebody tell me where that comes from. Pythagorean theorem. Pythagorean theorem. So, if I want to find the magnitude, notice how the magnitude is written. Why is it written as an absolute value? Because absolute value is basically, in physics and in math, what is absolute value? It's distance. The absolute value of -4 is 4. It's 4 spots from 0. The absolute value of +4 is 4. It's 4 spots from 0. The direction angle theta can be written as a tangent. Now, that's true always, but sometimes you're going to be asked for the x and the y. If you're asked for the x and the y and you're given the magnitude, then you do r sine theta, r cosine theta, which is probably going to follow this. But if you want to find the direction and you're given a and b, then you do tangent, which you should know that from your right angle trig. All right, so here's a vector. And all I'm going to do is I'm going to draw a line, and I'm going to do it in red. I'm going to draw a line right there. And now you have a triangle. And you can find, and all of you have had first, that first unit, we did nothing but right angle trig. So you should be able to find anything you want to about that triangle. Notice how the coordinate is written. That is a coordinate vector. That is the vector coordinate. It's written, it's got the less than or equal to brackets, so you know it's not a coordinate, it is a vector coordinate. And you plug and chug, the hypotenuse is equal to 13. The hypotenuse in this case is the position vector. Later, it's going to become the resultant vector, and you may have to use law of sines, law of cosines, or right angle trig. So this is one question you might see on the test. This is a homework question. This is where you actually start using trig to start doing vectors.
So the square root of the square root of 13 is the magnitude?
Yes.
Okay.
And the direction would be the tangent of Oscar had a hunk of apple. So here's your little man right here, right there. and that would be the Oscar had a hunk of apple. That would be of apple, which would be -2 over 3, and there it is right there. So our angle is -33.7. The negative refers to it's below 2 pi, or below 0 degrees. That's what they're saying right there. So if you wanted the positive vector, it would be 326.3. The horizontal and vertical vector components, respectively. There you go. If you want to find your x, the x is r cosine theta. And I'm going to go ahead and say r right here because you're going to see it later as r. Okay? And the vertical, the y is going to be r sine theta. So if you ever want to find the coordinates of a vector and you're given the magnitude, you just have to do r sine theta and r cosine theta. I mean, you're given the direction. To find the x, you do the r cosine theta and u sine theta. And they'll probably give you another example here next. There you go. So go ahead and do that one. Punch it in your calculator. X is equal to r cosine theta. Y is equal to r sine theta. And the reason I make it like that is because I don't want you to learn one way and then 2 or 3 slides later they change it on you. So I'm just going to go ahead and call it r sine theta and r cosine theta. So cosine is 41.7. So that's going to be 25 times the cosine of 41.7. Make sure it's in degree mode. And the y is equal to 25 times the sine of 41.7. And if y'all would crank that out, well, I'll just do the board. And when you do that, 18.7 is your x, and your y is 16.6. That's another test question. Now, it's probably going to be they're probably going to go into unit vector next and go into I and J, which I don't know if they're going to go into that now or go into polar coordinates. I don't know. We'll see if they're going to go that far. Okay, they're doing that in the calculator, and that's good. You can use, if you know how to use it, they're going from P to R and P to Y. You can do that. I don't like to do this, and I'll tell you why. Because if you don't learn the critical thinking now that's in the mechanics of trig and vectors, then you're going to fall flat on your face when you do a free body diagram. Okay, so I'm going to just kind of skip over that. And here it says write each vector in the form find your x and your y of each vector. So let's do our blue. And this is a test question. So I'm going to drop that right there. And we need an x and a y for that one. And that's going to be, what is that, 5? Okay, my x is equal to 5 cosine of 60. And y is equal to 5 sine of 60. I need you to crank that out. And that's going to give me that, comma, that. So, and again, I'm teaching those students that have never seen this before. That's the whole point of a teacher. Not to teach people that already know everything. So, what's 5 cosine of 60? I'm sorry, what?
2.5. 2.5.
Thank you. 10.5. And somebody do 5. What?
2.5.
Oh, I thought you said 10.5. Everybody was saying it together, which I'm glad. Thank you. I'm not fussing. 2.5. And somebody give me the other.
4.3.
Did you get 4.3, everybody?
Yes,
All right, now I'm going to let you do B, which will be in red. Now, of course, red is 180 degrees, so you really don't have to what? You really don't have to calculate it because you know that the unit circle, what's your sine and cosine? Cosine is -1. What's your sine? So, you know that the y is going to be 0. And what is the x? -2. So, you really don't have to do the red. But we're going to do it anyway. So, x is equal to 2 cosine of 180, which is that's going to be -1. And y is going to be 2 sine of 180. And you know the sine by the unit circle takes that out. So y is equal to 0. And x is equal to 2 times -1. So -2, 0. All right, now do the green and verde. So that's going to be x is equal to 6 cosine of 280. And y is going to be 6 sine of 280. And do your calculators. Give me the x.
1.
1.
And what's y?
-5.9.
Thank you. Now, those are 3 questions that you might see on the homework or the test. Now, they're going to get more involved. I mean, don't get me wrong. It's not going to be an easy section. But I want you to understand that it's very important for you in your other classes, especially if you're in engineering sciences. And it's going to show us. Now, they did it by the radicals. I'm not going to ask you to do it by the radicals because nobody's ever going to walk up to you and ask you for a radical at a construction site.
Oh.
What in the world was that?
That was Billy's water bottle.
Okay. All right, next.
Sorry.
And they're doing, there we go. Y'all got -5.9. Thank you. And that's supposed to be 1.04, people. 1.04, whatever. Okay, we talked about a parallelogram, opposite sides. I'm not going with diagonal. We talked about that. Here we go. This is a resultant vector. Okay. 2 forces of 15 and 22 newtons act on a point in a plane. Okay, so basically, you've got this point right here. Let's say you've got this point, and we're going to color it purple. Okay? Let's say that's a box, okay? And you're looking down on this box, and you got a force of 15 newtons with a cable pulling it this way, and you got a force going straight this way. You're looking down on top of somebody's head, on top of this box, and 15 pounds is going this way. I don't really care about the newtons. Y'all can get into that with physics. I'm going to just think. You got 15 pounds pulling this way, and you got 22 pounds pulling this way. Where is this box going to end up? And that's what the resultant vector is. Now, you've got 3 things. You got 15, 22, you could actually, and I think they're probably going to do this with, okay, yes. Okay, each measures 80 degrees. You're figuring basically a triangle. You're going to use the law of sines or the law of cosines. Right? So you've got 22 here, you got 15 here, you got 80 here, and 80 here. Now why? Because this is 100, therefore this is what? What is this right here? That's 100, Hubert. That's right, class. And then what's 100 plus 100? 200. And what's in a quadrilateral? 360. So you know you got 80 here and 80 here. That's how they're getting that. Now they're probably going to use the, well, I don't know if they, okay, they're just, okay, there it is. So your vector is basically using the law of what? Cosines is 24 newtons. So this vector is 24 newtons if it's being pulled 22 this way and 15 this way. Well, why is it so close to this one? Because it's being pulled away. That's why. If you had a vector going down this way, it would be more because this vector down this way would be helping this vector down this way. Okay, you've got to, when you're talking about vectors, and that's where the critical thinking comes in. When you're talking about a vector, you've got to put that box at a cross right there. Now, if that vector is in the same quadrant, if the two vectors are in the same quadrant, it's helping. If it's in a different quadrant, it's not helping. Everybody with me?
Yes.
Okay? So you have to think about that when you're drawing a free body diagram. So your answer should come out close to the main vector. But if you had the same quadrant, then it would be helping, so it would be probably more than this vector. Now that, again, this is, and you need to write that down, law of cosines. Make sure you just write these down right quick because this basically says that you can add vectors because we're going to get down to a unit vector and we're going to get to a dot product. I don't know if we're going to get to a dot product. Hopefully we will. You're going to be multiplying vectors, dividing vectors. So you can add a vector. A plus C is B plus D. You can multiply by a scalar, which means you get, if this was 1 and this was 1 and this was 5, then the unit vector would be 1. You multiply by the scalar, that gives you the position vector. And that's what that one does. And of course, if you have a vector going in the positive direction, then the vector going in the negative direction would be the negative coordinates. That's pretty self-explanatory. And of course, if you are subtracting a vector, you subtract C and D. Now, those are pretty basic, but again, for the person that's never seen a vector, when we get to the dot product and we get to finding the different kinds of vectors, you will see some of these properties go into effect. Question?
Hold on.
Okay.
Okay, you can go
And
now.
these are also in your book also, and I'm going to pull up a cheat sheet with trig. You can go to trig vectors cheat sheet and print you out one. Again, you'll have to actually, print out and, get a couple of buttons, so it's a lot of work. So if I take -2 and 1 and B, what happens when I do these following operations? Well, what's -2 plus 4?
-2.
-2 plus 4 is what? 2. So this one would be 2, comma, what's 1 plus 3? 4.
4.
Okay? 2u, negative 2u would be negative 4, sorry, positive 4, comma, negative what? 2. 3u, 3 times, okay, so that's going to be 3, it'll be negative 2, negative 6, and 3, minus 2, the 8, and what? 6? What's negative 6 minus 8? It's negative 14. And what's 3 minus 6?
Negative 3.
Sounds like some of y'all need to brush up on your signs. But y'all probably already know this anyway, right? Alright, so there's the first one. 2 and 4. And they're showing you where these are. And there, you multiply 2 times that, you get what? 4 and negative 2. And the last one, they're writing everything out, so what did I get? Did I get that? I hope I did.
I think so.
So, as you can see, the math is not that difficult. But what happens is people don't remember the first part of what I showed you, and they forget stuff, and that's why these simple problems, they get wrong on a test. There we go. I figured we'd get to unit vector pretty soon. Remember, what is the unit that you have been studying in trig? The unit circle. Unit circle has a radius of what?
360.
1. So write that down. Radius is equal to 1. So if I have a vector, and let's say this vector is, I got a magnitude of 4. Everybody with me? Then the unit vector is the vector that's represented at r is equal to what? 1. So you have a unit vector inside all vectors. And it's very important for some of y'all to write down. The unit vector is a vector whose magnitude is always what?
1.
1. So make sure you write that down, because that's where the term unit vector comes from. It comes from the unit circle. And that's where all your directions come from, because everything is based on the unit circle. So if I wanted to find out what the magnitude of the circle, or what the unit vector is, I would take the magnitude of 4 and divide by 4, and that would give me 1. And I think they give you, the unit vector over the magnitude of the unit vector is equal to 1. Now, look at this. We have I and J. I means X. J means what? Y. And that's where you see, but when you see I and J, they are talking about the unit vector. So from here on out, if you're in physics, dynamics, thermodynamics, whatever the case may be, when you see I and J, you're in context of the unit vector. So you could rewrite vector AB in terms of the unit vector by saying a number I plus a number J. Now you're also going to see this in polar coordinates too. They're going to give you an example here in just a second. It'll make sense. tell you right now, there's a lot of people that think they know vectors, but when you get to a scaling vector, or you get to a, dot product, or you get to some of that, vector stuff, they have forgotten a good bit. They should, yep, there's one, dot product. The dot product is not a vector, okay? The dot product is basically used in calculations, all right? The dot product of two vectors, U and C, is going to be AC plus BD. Now, the dot product, and I want you to write this down, is only used in calculations. It does not mean that you got a new vector called dot product. Okay? It's only used in calculations. So, basically, you remember how I showed y'all, I don't remember if it was this class, or 110 or 109, and I showed y'all how to do Kramer's rule. 1, 2, 3, 4. And you do this, and that's going to be 1 times 4 minus 3 times 2. I don't know if I showed y'all this or not, but 4 minus 6 is what? 4 minus 6 is -2, so that is the determinant of this matrix. Well, that's kind of like what you're doing here. You're taking A times C, and you're adding B times what? D. It's kind of like doing a determinant for a vector. And this number will only be used with calculations. And you will see this until you graduate engineering or science. Okay? So what is the dot? I'll probably give you one here. There we go. 2 times 4 is 8. What's 8 plus a -3? 5. So the dot product of those two vectors is 5. Same thing there. That's a unit vector, but 6 times -2 is -12. And what is -12 plus 12? 0. So you've got a dot product, and dot product of 0 means something later, but we're not going to get into it now. 2 times 3, that's going to be, what did I say? I done forgot. 5? That should be 5. Now I'm going to leave this on the board for a second. And then that one. Is that what I got? 0? Did I get 0? I think I did. Yeah. Okay, write this down, because this is one of the first things that people get confused on with vectors. Remember, the dot product is only for calculations. Nobody's ever going to walk up to you and say, I've got two vectors here, can you give me the dot product? Nobody's ever going to walk up to you. But you will see here in the next few slides, I think, you will see why we use the dot product. I'll give you a couple more minutes. You got the first one down, or what?
I got them both.
You got them both? How about you, Pendleton? You got them all?
No, hold on.
Okay. Easley, you got them?
Yes.
And Miss Payne and Mr. Wilson?
Yeah, I got it.
Okay, I'm good now.
Okay, good? All right.
Yes.
Now, for all vectors U, V, and W, sorry, I can't say W, that's not, I'm racist. W, and real numbers K, the following hold. And most of these are same thing you learned back in 2nd grade. Commutative law, associative law, distributive law, multiplicative law, the theory of 0, which if you multiply anything by 0, you get 0. And you can multiply a vector times a vector and get a vector squared. Okay, this is not really anything that's detrimental, but some people look at a vector and don't, I don't know if I can multiply it. Yes, you can. All right, you don't do it a lot, but you can do it. Now, here in a minute, we're going to take u dot v and use it, and we're going to do the distance on the denominator and the dot product on the top. And I think we're going to get there eventually. And you'll see that you can use some of these. And we used them a while ago when we multiplied the -2 times the vector, and we added the vectors. So these are things that pretty much y'all should know. Remember, when you're dealing with vectors, you're not dealing with numbers. You're dealing with a direction and a magnitude. Okay? You have been dealing with numbers up until trig. Okay? Then we threw in the angles, and now you're putting in a weight or a measurement or a distance or a volume with a direction. So it's a little bit different thinking. There we go. And this is called the angle between two vectors. The cosine of theta is equal to the dot product of uv over the magnitude of u times the magnitude of v, or u dot v. Now you notice how I said that? U dot v. You need to write that down because that's what it's going to be called. Whenever you hear u dot v, whenever you hear x dot y, whenever you hear anything dot anything, that automatically means what? Dot product. And I'm going to put that up here. U dot v. Well, I don't need to write it like that. I need to write it with the little word dot. Sorry.
So that's like the u times v is u dot v?
Yes, but it's not multiplication.
Sure.
Because multiplication is with a scalar, and that means this is multiplication. You know, when you have, sorry, let me write that. This is a multiplicative vector. 3, 2, there we go. That's multiplication.
Okay.
And you could do 2 times the actual magnitude, which would be 2 times 5 is 10. You can do that. But I don't want you to think that's u times v, because it's not. It's u dot v. Does that make sense?
Yeah.
All right? Where the angle is between the 180. Now remember, you can find u dot v, and you can derive and find the angle using cosine is equal to u dot v over the magnitude of u times the magnitude of v. And you can put a little asterisk here if you want to. Okay? And they're going to give you an example here next. There we go. Find the angles between the two vectors. Now, I'm going to draw these vectors because, you know, that's just something I do. I don't know if they're going to do it, but I'm going to do it. So, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So, 4 and 3. That's one vector. And again, that's a position vector. And then V is 2, 1. So 1, 2, 1. So they're wanting to know that angle right here between these two vectors. Now, could you do head to tail and all that stuff? Yes, you could. You could use the law of sines. You can use the law of cosine. But that's a lot of extra what? Work. And I know some of y'all hate extra work. That's kind of like hating raising the bar. You hate extra work. So we're going to do u dot v, the cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. So I want you to go ahead and do u dot v. U dot v is going to be 6 plus what? 4, which is 10. So already you got 10 in the numerator. And we'll check it, make sure. Yeah. So 10 is going to be in the numerator. And then what is the magnitude? Well, we got to find the magnitude because we really don't know. So I'm going to drop this down. So our x, our y is what? Our y on the 3, 4 is what? 4? And 3 squared is 9. 4 squared is 16. 9 and 16 is 25. So 5. And then we got, right here, we got 2 and 1. 2 squared is 4. 1 square root of 5. Right? Somebody check me.
How did you get that? I'm sorry.
Using Pythagorean theorem.
Okay.
Okay, first of all, what's 3 times 2?
6.
What's 4 times 1? What's 6 plus 4? That's U dot V. U dot V is 10. And then, what is the magnitude of U? Well, I have to take 4 squared plus 3 squared is equal to 4 squared plus 3 squared is equal to 25 squared. 25 is equal to 5, so that's where I got that. Now somebody check me on the other one. 2 squared is 4. 4 plus 1 is 5. Square root of 5 should be the little one. And I don't know if they want you to use, I'm going to use, since we're in academia and we don't do real world, I'm going to do it with the radical. Because that counts for nothing out in the real world. So anyway, 10 times 5, square root of 5, multiply square root of 5, square root of 5. So that's going to be 10 times square root of 5 over 5 times 5. Everybody with me? And 10 over 5 is what? 2. So that's going to be 2 square root of 5 over what? So that's probably going to be your answer for the first one. Now, a lot of you may say, well, Hubert, you're kind of going a little fast. Most of you should know what I'm doing. Because what have I done? The only thing different that I've done is the U dot V. That's the only thing different I've done. Why? Because you know the Pythagorean theorem. You know how to find the hypotenuse of a triangle. And what are these two little things right here? Take my red marker. What is this? That's a triangle. And what is this? Well,
A bigger
I don't know
triangle.
why I did that, but I suck. Let me try that again. That is a big triangle. All right, now I want you to do B. First, let me check to make sure. They may want it in decimal form. I doubt it, because decimal form you use in the real world. Oh, wow. Right? That's all I got to do is when I think they want in academia, they'll do it in the real world. So somebody take 2 square root of 5, which will be 5.7 or 5.4. What's 5.4 over 5? It's going to be a little bit, I don't know if 2 times, what's 2 times square root of 5 over 5? Is that 0.89?
Yeah, it is.
Okay.
Yep.
All right, y'all do the next one. Now, I will probably put several of these on the test. Why? Because this is very, very, very important. Oh, we didn't take the cosine. You got to take the inverse cosine of 0.89. Sorry. Take the inverse cosine. Somebody take the inverse cosine of 0.8, blah, 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 blah. There you go. There's the angle. 27 degrees. Don't forget to take the inverse cosine. What is that? Dang old biology. Dang old eating them dang old worms. That's why we have to worm our cattle. Horses is worse. You might know why horses get more parasites than cows? Because they dang old eat the grass, dang old down to the dirt. That's why they get more parasites. That's why I don't have horses. I sold my horses. I can't babysit. When you have horses, you have to babysit. That's why cows are the best livestock, because you worm them twice a year, and that's it. That's all you have to do. Goats, they die. They get a cold and they die. Sheep, they die. Pigs, you can't keep pigs up because they get out. I'm sorry, I should shut up. Anybody up there at Pendleton got any livestock?
No.
No.
How about Easley? Miss Payne, Wilson?
No.
Yes, sir.
Nope.
Daggone.
I got a brother.
You got a brother? Does that count as livestock?
Depends on the day.
Okay, depends on the day. Well, most men can be bastards anyway, you know that. All right, there you go. There's a white board there. So 2 times 6 is 12. 12 minus 12 is what? Okay, so you forget doing this one. Why? Because what's 0 divided by anything? 0, Hubert. Right?
Right.
So do the inverse cosine of 0. Which angle has a cosine of 0?
90.
90.
90 and 270, right? So it's either probably going to be 90, because usually most of these are between 0 and 180. So it's probably going to be 90. There you go. So should you have done this whole thing?
No.
No, you should have stopped as soon as you got a dot product of 0. Anything into 0 is 0. So I would say probably 90 degrees. Ding! We feel good about ourselves. So you might want to write this down too. For angles between 0 and 180, and that's usually what these are done, because until you get into until you get into physics, you're not going to have too many negative forces. So most of them are going to be up in the top area at 180. So for right now, for cosine, the dot product is going to be positive. And angles between the vectors are going to be acute. If you have a cosine of 0 and a dot product of 0, that goes hand in hand. It's going to be a right angle. And then if you have a negative or a negative, it's going to be obtuse, which means more than 90 degrees. Do you use this a whole lot? Not much. But it will tell you, if you do get a dot product, this is what you need to look at right here. If you have a dot product that's positive, that's normal. You're going to have acute. If you have a dot product of 0, you're going to have a right. And if you have a dot product of negative, you're going to have obtuse. Like the warden on Shawshank Redemption. And I guarantee you, y'all have never seen that movie. One of the great movies of all time. Y'all don't watch it because they don't have computer graphics. A ship leaves port right quick. Somebody's having convulsions. What time is it?
12:31. You got 4 minutes.
Okay. Go ahead and write this one down, and you can work on it for homework. I don't expect you to be able to do 11.3. I do realize that some of you invented vectors, but most of you are not going to be able to do 11.3. I want you to continue to work on 11.1 and 11.2. Go ahead and write this one down and see if you can figure it out without any help. And this is where we'll start Thursday. Now, my plans are to finish up Thursday with 11.1 through 11.3. I want to give you a test on 11.1 through 11.3. So chances are I will go ahead and assign a test Thursday for 11.1 and 11.3. But I'm going to give you Tuesday of next week to go over questions and to go over the test. Is everybody with me? And then you have, I'm going to make the rest of the Thanksgiving holidays for you to finish the test and the homework on 11.1 through 11.3. Does everybody get that? You are welcome. I'm giving you plenty of time to do 11.1 through 11.3. All right, y'all get out of here and have a good day, and I'll see y'all Thursday.
So, like,